So see, from current electricity, actually idral ನೀವು ಏನೇನ್ ಸ್ಟಡಿ ಮಾಡ್ತೀರಾ ಅಂತ ಅಂದ್ರೆ, that is what do you mean by electric current ಅಂತ ಬರುತ್ತೆ. Then we have the Ohm's law. Then after Ohm's law, resistance, resistivity factor. Then actually resistors connected in series, parallel. Then cells connected in series, parallel, meter bridge, potentiometer. These are the points which we will learn in this lesson. But ಈ ಅಕಾಡೆಮಿಕ್ ಇಯರ್ ಅಲ್ಲಿ ಏನೇನ್ ಡಿಲೀಟ್ ಮಾಡಿದ್ದಾರೆ ಅಂತ ಅಂದ್ರೆ, ದಟ್ ಇಸ್ ರೆಸಿಸ್ಟಿವಿಟಿ ಆಫ್ ವೇರಿಯಸ್ ಮಟೀರಿಯಲ್ಸ್. ಸೊ ಕಲರ್ ಕೋಡ್ ಅಂತ ಹೇಳುವ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಇತ್ತು ಲಾಸ್ಟ್ ಇಯರ್ ವರ್ಗೆ. ದಟ್ ಇಸ್ ರೆಜಿಸ್ಟರ್ ಬ್ಯಾಂಡ್ಸ್ ಇರುತ್ತೆ, ಅದ್ರ ಮೇಲೆ ಕಲರ್ ಕೋಡ್ ಕಲರ್ಸ್ ಇರುತ್ತೆ. ಬೇಸ್ಡ್ ಆನ್ ದಟ್ ಯು ಹ್ಯಾವ್ ಟು ಐಡೆಂಟಿಫೈ ದ ರೆಸಿಸ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂ. ಸೊ ರೆಸಿಸ್ಟಿವಿಟಿ ಆಫ್ ವೇರಿಯಸ್ ಮೆಟೀರಿಯಲ್ಸ್, ದಟ್ ಇಸ್ ದ ಕಾರ್ಬನ್ ಕೋಡ್ ರೆಜಿಸ್ಟರ್, ಕಲರ್ ಕೋಡ್ ರೆಜಿಸ್ಟರ್, ಅದನ್ನ ಡಿಲೀಟ್ ಮಾಡಿದ್ದಾರೆ. Then combination of resistors, that is series combination, parallel combination, that is also deleted for this academic year. Then meter bridge, potentiometer. Actually Wheatstone bridge kalitivi, adr mele erden application barutte. So that is Wheatstone bridge and meter bridge and the potentiometer, adu kuda delete agide. So adan bitte enen points ide adana navu illi cover ಮಾಡ್ತಾ ಇದೀವಿ. So let us start with the class. Okay, the first question, ನೀವು ಬ್ಲೂ ಪ್ರಿಂಟ್ ನಿಮ್ಗೆ ನೆನಪಿರ್ಬೋದು. ಸೊ ಈ ಲೆಸನ್ ಮೇಲೆ ಸೇಮ್ ಕಂಪಲ್ಸರಿ MCQs ಅಂತೂ ಬಂದೇ ಬರುತ್ತೆ. ಸಿಮಿಲರ್ಲಿ ವಿ ಹ್ಯಾವ್ 1 mark and we have 2 mark question, 5 mark question based on this topic. Okay, so let us see here one by one. First MCQs ನೋಡೋಣ. ಗೊತ್ತಿದ್ರೆ ನೀವು ಇಲ್ಲಿ ಆನ್ಸರ್ ಹೇಳ್ತಾ ಹೋಗ್ಬೋದು. Yes, see the first question. Kirchhoff's junction rule signifies the law of conservation of. Yes, ಯಾರಿಗಾರಿಗೆ ಗೊತ್ತಿದೆ ಆನ್ಸರ್ ಹೇಳ್ಬೋದು. Kirchhoff's junction rule signifies the law of conservation of. So actually we have two laws here, that is Kirchhoff's first law and the second law. So it is also called as junction rule and the voltage rule anta kuda ಹೇಳ್ತಾರೆ. So here all the students are answering, it is option C, that is electric charge anta. Yes, so option C is the correct answer. So here as I told you, there are two laws in Kirchhoff's laws. So Kirchhoff's ಎರಡ್ laws alli the first law is based on the conservation of charge. So first law enide, so first law is based on the conservation of charge anta ಹೇಳ್ತಾರೆ. That is current entering to the system is equal to current leaving to the junction anta. So it is also called as the junction rule. Second law states that the algebraic sum of the potential difference in a closed circuit is equal to 0. So that is giving the conservation of energy. So ಎರಡು ನೆನಪಿರ್ಲಿ. Second law conservation of energy, first law is conservation of charge. Okay, so it is not that ade barutte anta. So second law mele kuda question barbodu. Go for the second question. Kirchhoff's loop rule is the consequence of law of conservation of. So everybody is saying option B. Yes, option B, just now we have discussed. Yes, correct agide. So option B, that is energy. Go for the next question. Drift velocity per unit electric field is called relaxation time, conductivity, current density, mobility. So in kelta idare, that is drift velocity per unit electric field, it is called as. Okay, 1, 2, 3, option D, A, all are giving different answer. It is option D, that is mobility. So mobility anta ಹೇಳ್ತಾರೆ, that is the ratio of drift velocity to the electric field is called as what? Mobility. ಆಯ್ತಾ? So conductivity is the reciprocal of resistivity anta ಹೇಳ್ಬೋದು. Current density anna current per unit area anta ಹೇಳ್ತಾರೆ. Okay, relaxation time is given by, relaxation time is denoted by tau. It is the average time interval between the two successive collision of the electrons. The average time interval between the two successive collision of the electron is called as what? that is drift velocity. Okay, the next question. So see what is the next question. The resistance offered by a 1 meter long conductor having a cross-sectional area 1 square meter is called. Yes, the question is what, students, here? The resistance offered by a 1 meter long conductor having area of cross-section 1 square meter is called. Options: electrical resistance of the conductor, electrical resistivity of the conductor, electrical conductance of the conductor, electrical conductivity of the conductor. The resistance offered by the any substance for 1 meter long conductor having 1 meter square area, it is called as resistivity. So ನಿಮಗೆ resistivity ಗೊತ್ತಿರಬಹುದು. That is, we have the formula for resistance. So resistance ಯಾವ ರೀತಿಯಾಗಿ ಬರಿತೀವಿ? R is equal to rho into L divided by A ಅಂತ ಬರಿತೀವಿ. Suppose if I substitute L is equal to 1 meter, A is equal to 1 meter square, or avagénagate, that is R is nothing but here rho. So here the resistivity is nothing but the resistance when the area is 1 meter square and the length is 1 meter. Aita? Hope so it is clear to everyone. So option B, electrical resistivity anta ಹೇಳ್ತಾರೆ. So ನೋಡಿ, how much detail ಆಗಿ ನೀವು ಸ್ಟಡಿ ಮಾಡ್ಬೇಕಂತ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗ್ತಾ ಇರಬಹುದು MCQs ನೋಡಿ. So you have to understand ಏನು ಓದ್ತಾ ಇದ್ದೀರಾ ಕರೆಕ್ಟ್ ಆಗಿ ತಿಳ್ಕೊಂಡು ಓದಿದ್ರೆ MCQs ಆನ್ಸರ್ ಮಾಡ್ಲಿಕ್ಕೆ ಈಸಿ ಆಗತ್ತೆ. Yes, just now we discussed 6th question answer. ಯಾರಾದ್ರೂ ಹೇಳ್ಬೋದಾ? Average time between two successive collisions is called as. Average time between two successive collisions is called as relaxation time, conductivity, current, electricity, mobility. Yes, very good. Option A, that is relaxation time. Option A, relaxation time anta ಹೇಳ್ತಾರೆ. Okay. Go for the next question, that is question number 7. Constantine and magnine wires are used in making standard resistance boxes because they have. So for example, actually ನಿಮಗೆ potentiometer ಮತ್ತೆ meter bridge delete ಆಗಿದೆ. So if you see that ಅಲ್ಲ, by chance ನೀವೇನಾದ್ರೂ instrument ನೋಡಿದ್ರೆ, whatever that meter bridge and this one meter bridge and potentiometer ಏನಿದೆ, ಅದ್ರ ಮೇಲೆ ಏನ್ ವೈರ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ, ದಟ್ ವೈರ್ ಇಸ್ ಮೇಡ್ ಅಪ್ ಆಫ್ ಕಾನ್ಸ್ಟಂಟಿನ್ ಆನ್ ಮ್ಯಾಗ್ನೈನ್. ಓಕೆ, ಸೊ ಯಾಕೆ ಅದನ್ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ ಇಲ್ಲಿ. ವೈ ದೇ ಆರ್ ಯೂಸಿಂಗ್ ದೋಸ್ ಟು ಮಟೀರಿಯಲ್ಸ್ ಓನ್ಲಿ? ದೀಸ್ ಆರ್ ದಿ ಅಲಾಯ್ಸ್. ಓಕೆ, ಆಕ್ಚುಲಿ ಇದೆರಡು ಅಲಾಯ್ ಇದೆ. ಯಾಕೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ? ಆಪ್ಷನ್ ಎ, ಲೋ ಟೆಂಪರೇಚರ್ ಕೋಎಫಿಷಿಯಂಟ್ ಆಫ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಂಡ್ ಹೈ ರೆಸಿಸ್ಟಿವಿಟಿ. ಆಪ್ಷನ್ ಬಿ, high temperature coefficient of resistance and low resistivity. Low temperature coefficient of resistance and low resistivity. Option D, high temperature coefficient of resistance and high resistivity. Yes. So Vedavati is saying option C. What about other students? Yes. Constantine and magnine are used for making the standard resistance boxes. Okay, yes. So here the correct answer is option A, that is high resistivity and low temperature coefficient of resistance. So option A, high resistivity and low temperature coefficient of resistance. A is the correct answer, students. A, okay, not C, A. So C, sorry, A option. So to achieve the good resistance values in a small size, they prefer these two alloys. To achieve the ರಿಕ್ವೈರ್ಡ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ವ್ಯಾಲ್ಯೂಸ್ ಇನ್ ದ ಸ್ಮಾಲ್ ಸೈಜ್, ಯಾಕಂದ್ರೆ ಅಷ್ಟು ಕಾಂಪ್ಯಾಕ್ಟ್ ಆಗಿರುತ್ತೆ ಡಿವೈಸ್. ಸೊ ಅದ್ರಲ್ಲಿ ನಿಮ್ಗೆ ಏನ್ ರಿಕ್ವೈರ್ಡ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಬೇಕು ಅಂತ ಅಂದ್ರೆ ಇಟ್ ಶುಡ್ ಸ್ಯಾಟಿಸ್ಫೈ ದಿಸ್ ಕಂಡೀಷನ್, ಹೈ ರೆಸಿಸ್ಟಿವಿಟಿ ಮತ್ತೆ ಲೋ ಟೆಂಪರೇಚರ್ ಕೋಎಫಿಷಿಯಂಟ್ ಇರಬೇಕು. ಆಯ್ತಾ, ಆಪ್ಷನ್ ಎ ಇಸ್ ದಿ ಕರೆಕ್ಟ್ ಆನ್ಸರ್. ನೆಕ್ಸ್ಟ್, SI ಯೂನಿಟ್ ಆಫ್ ಕರೆಂಟ್ ಡೆನ್ಸಿಟಿ ಇಸ್. ಆಕ್ಚುಲಿ ಇಲ್ಲಿ ಮೇಲ್ಗಡೆ ಒಂದು ಕ್ವಶನ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ನಾನು ನಿಮ್ಗೆ ಹೇಳಿದ್ದೆ ಕರೆಂಟ್ ಡೆನ್ಸಿಟಿಯನ್ನ ಯಾವ ರೀತಿಯಾಗಿ ಬರೀತಾರೆ ಅಂತ. Yes, the SI unit of current density is. So current density is given by, so current density is equal to, it is current per unit area anta ಹೇಳ್ತಾರೆ. So ಇಲ್ಲೇನಾಗುತ್ತೆ, current is expressed in terms of ampere, area is expressed in terms of meter square, therefore it is ampere per meter square. Option C is the correct answer. Okay, option C, ampere per meter square. Yes, very good. 8th question completed. 9th question ಗೆ ಬನ್ನಿ. SI unit of resistivity is. SI unit of resistivity is. Ohm, ohm meter, ohm per meter square. C, B is Priyanka, B option, Netravati, B option. So resistivity ಇಲ್ಲಿ ನೋಡಿ, if you don't know you can check this. R is equal to rho into L by A ಅಂತ ಹೇಳ್ತಾರೆ. ಆಯ್ತಾ, so resistance is ohm, length is meter, area is meter square. So meter cancel ಆದ್ರೆ ಉಳಿಯುತ್ತೆ ಏನು, that is ohm per meter. Okay, ohm per meter. Option C is the correct answer. ಆಯ್ತಾ, yes, C option. Okay, the next one, SI unit of conductance is. So always you remember, so now ಏನೇನ್ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ ನೋಡಿ, ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಂತ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. ರೆಸಿಸ್ಟೆನ್ಸ್ is nothing but the opposition for the flow of current is called as resistance. It is expressed in terms of ohm. The reciprocal of resistance is called as conductance ಅಂತ ಹೇಳ್ತಾರೆ. The reciprocal of resistance is called as conductance ಅಂತ ಹೇಳ್ತಾರೆ. So resistivity ನೋಡಿದ್ವಿ, resistivity is given in terms of ohm per meter. And the reciprocal of resistivity ಅನ್ನ conductivity ಅಂತ ಕರಿತೀವಿ. ಆಯ್ತಾ, hope so you are understanding. Yes, now conductance is reciprocal. ಏನೇನ್ ಕೊಟ್ಟಿದ್ದಾರೆ, that is MHOM ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, mom ಅಂತಿದೆ, MHO ಅಂತ ಇದೆ, mho ಅಂತ ಇದೆ. Sorry, first one is meter ohm, second one, third one is meter per ohm, meter per ohm square. ಈಗಾದ್ರೂ ಹೇಳ್ಬೋದಾ? Here I have written, see, resistance is the opposition for the flow of current. Ohm in the express ಮಾಡ್ತೀವಿ. Conductance, the resistance reciprocal is called as conductance. See, no, I'll repeat. See here, students. So resistance is nothing but the opposition for the flow of current is called as resistance, and it is expressed in terms of ohm. Conductance is the reciprocal of resistance. So ಇದನ್ನ per ohm ಅಂತ ಬರಿಬಹುದು ನೀವು, ಹೌದಾ? You can write it as per ohm. You can also write it as per ohm ಅನ್ನ MHO, mho ಅಂತ ಹೇಳ್ತಾರೆ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? So option B is the correct answer. Yes. So here next ಮತ್ತೊಂದು ಪಾಯಿಂಟ್ ಹೇಳ್ತೀನಿ ನೋಡಿ, before going for the 11th question. So 11th question is related to what I'll explain you. Resistivity ಅಂತ ಬರುತ್ತೆ. So resistivity unit ಅನ್ನು ಈಗಷ್ಟೇ ನೋಡಿದ್ವಿ, ohm per meter ಅಂತ ಇತ್ತು. The reciprocal of resistivity is called as what? Conductivity. So ಇಲ್ಲಿ conductance ಅಂತ ಹೇಳಿದ್ವಿ, ಇಲ್ಲಿ conductivity ಅಂತ ಹೇಳ್ತೀವಿ. So 11th question ಅಲ್ಲಿ ಏನೇನಿದೆ ಆಪ್ಷನ್? meter, mho, then meter, mho square, meter, ohm per ohm, meter per ohm square. Yes. So according to the given option C, because ಇದು reciprocal ಆಗಬೇಕು. So ಇದ್ರದ್ದು reciprocal ಅಂದ್ರೆ per ohm ಆಗತ್ತೆ, ಇದು meter ಆಗತ್ತೆ. So that is option C. ಹೌದಲ್ಲ? Yes, agree? Yes, correct. Hope so you agree with the point. If you are not understanding, please ask. Okay. So ಇದನ್ನೇ ಸಿಂಪಲ್ ಆಗಿ ಸೈಮನ್ ಅಂತ ಕೂಡ ಹೇಳ್ತಾರೆ, SIEMEN ಅಂತ. Okay. So that is also same, conductivity use ಮಾಡಬಹುದು. The next question. Okay, students, I am going for question number 12 ಆಯ್ತಾ. So 11th ವರೆಗೆ ಯಾರಿಗಾದ್ರೂ ಏನಾದ್ರೂ ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ. So 12th question proceed ಆಗ್ತಾ ಇದೀವಿ. SI unit of mobility is SI unit of mobility. What is the SI unit of mobility? So options ಏನೇನಿದೆ ನೋಡಿ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. Meter square per volt per second, per meter square volt second, meter per volt per second square, per meter volt second square. So mobility and ಯಾವ ರೀತಿಯಾಗಿ ಡಿಫೈನ್ ಮಾಡಿದ್ವಿ? Mobility is expressed in terms of drift velocity per unit electric field ಅಂತ ಹೇಳಿದ್ವಿ. So drift velocity ಅಥವಾ ವೆಲಾಸಿಟಿಯನ್ನ ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಇಂದ ಹೇಳ್ತಾರೆ. Then electric field ಅನ್ನ ವೋಲ್ಟ್ ಪರ್ ಮೀಟರ್ ಇಂದ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡ್ತೀವಿ. So if you simplify this, ಇದು ವೋಲ್ಟ್ ಪರ್ ಮೀಟರ್ ಇದೆ, ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಇದೆ, ವೋಲ್ಟ್ ಪರ್ ಮೀಟರ್ ಪರ್ ವೋಲ್ಟ್ ಇದು ಮೀಟರ್ ಆಗುತ್ತೆ. ಸೊ ಮೀಟರ್ ಇಂಟು ಮೀಟರ್, ಮೀಟರ್ ಸ್ಕ್ವೇರ್. ಸೊ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಪರ್ ವೋಲ್ಟ್ ಪರ್ ಸೆಕೆಂಡ್. ಆಪ್ಷನ್ ಎ ಇಸ್ ದಿ ಕರೆಕ್ಟ್ ಆನ್ಸರ್. ಸೊ ಪ್ರೂಫ್ ಕೂಡ ನಿಮ್ ಸೈಡ್ ಅಲ್ಲೇ ಇಲ್ಲಿ ಬರಿತಾ ಇದ್ದೀನಿ. The mobility is expressed in terms of drift velocity per unit electric field. Drift velocity is meter per second and electric field is volt per meter. So if you simplify, you will get option A. Yes, check. Okay. So 13th question. 13th question actually meter bridge delete agide, but ನೀವು college ಅಲ್ಲಿ study ಮಾಡಿದ್ದೀರಾ? Please tell me in the chat box. Meter bridge you have studied? No, ala? Okay, some are saying they have studied, some are saying they have not studied. Okay, so ಗೊತ್ತಿರ್ಲಿ ಅಂತ ಹೇಳ್ತೀನಿ, because not for the board, it will help you for the competitive exam part also. So ನೋಡಿ, ಒಂದ್ ವೇಳೆ ಬಂದ್ರೆ ಬರೀರಿ, ಇಲ್ಲ ಅಂತಂದ್ರೆ ಬಿಡ್ಬೋದು. The principle of working of a meter bridge is, that is electromagnetic induction, mechanical effect of electric current, balanced Wheatstone bridge, magnetic effect of electric current. So question ಯಾಕೆ ಕೇಳಿದ್ದಾರೆ ಅಂತ ಅಂದ್ರೆ, because this is based on the Wheatstone network. ಆಯ್ತಾ? ಸೊ Wheatstone network ಎರಡೇನ್ ಅಪ್ಲಿಕೇಶನ್ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ, ಮೀಟರ್ ಬ್ರಿಡ್ಜ್ ಮತ್ತೆ ಪೊಟೆನ್ಶಿಯೋಮೀಟರ್. ಅದ್ರದ್ದು ಡೀಟೇಲ್ ಸ್ಟಡಿ ಇಲ್ಲ, ಜಸ್ಟ್ ಇಲ್ಲಿ ಪ್ರಿನ್ಸಿಪಲ್ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. ಅಂಡ್ ದಿಸ್ ವರ್ಕ್ಸ್ ಆನ್ ದ ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಆಪ್ಷನ್ ಸಿ, balanced Wheatstone bridge. Okay, it is working on the balanced Wheatstone bridge. Option C is the correct answer. Yes. Okay, question number 14, students. Resistance of a conducting wire depends on length, area, temperature, all of these. Yes. Yes, it depends on all of these. Option D is the correct answer, students. Very good. Okay, so go for the next question. Question number 15. Resistivity of a conducting wire depends on. This is also D. ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. Length, area, temperature, none of this. Yes, very good. So if you tell your name, it will be good. What is your name? See, the resistivity of a conducting wire depends on, ಇಲ್ಲಿ ನೋಡಿ, resistivity ಎದ್ರ ಮೇಲೂ ಡಿಪೆಂಡ್ ಆಗಿಲ್ಲ ಆಯ್ತಾ. Resistivity is not depending on any of the things. It is constant for the given material. Resistivity is constant for the given material. It does not depend on length, area, ಎದ್ರ ಮೇಲೂ ಡಿಪೆಂಡ್ ಆಗಿಲ್ಲ. So ಕೊಟ್ಟಿರೋ material ಗೆ constant ಇರುತ್ತೆ. Therefore option D is the correct answer. Okay, the next question. Next question, resistance of a conducting wire increases when? So resistance of a conducting wire increases when? Yavag increase agate? Area increases, temperature decreases, length increases, none of these. Resistance of the conducting wire increases. Resistance of the conducting wire increases. B, C. B ಅಂತೂ ಬರಲ್ಲ. ಟೆಂಪರೇಚರ್ ಡಿಕ್ರೀಸ್ ಆದಾಗ ರೆಸಿಸ್ಟೆನ್ಸ್ ಟೆಂಪರೇಚರ್ okay, all are saying C. Yes, option C is correct answer. That is when the length increases. So length increase ಆದಾಗ ಏನಾಗತ್ತೆ ಅಂತಂದ್ರೆ the resistance increases because we know that R is proportional to L and inversely proportional to area. So area decrease ಆಗಬೇಕು, resistance ಹೆಚ್ಚಾಗತ್ತೆ. Length ಹೆಚ್ಚಾಗಬೇಕು, resistance increase ಆಗತ್ತೆ. Okay, so go for question number 17 now. After that, after 5 questions, we have the 2-3 marks questions. Resistors in the higher range are mostly made from silicon, copper, aluminium, carbon. Resistors in a higher range are mostly made from. So high value ಅಥವಾ high range resistors ಎದರಿಂದ ಮಾಡಿರ್ತಾರೆ? So usually it is made from the carbon ಆಯ್ತಾ. So carbon ಅಥವಾ carbon alloys ಇಂದ ಮಾಡ್ತಾರೆ. So ಇಲ್ಲಿ silicon, copper, aluminium ಗಿಂತ carbon is used appropriately to make the resistors. ಅಥವಾ ಕಾರ್ಬನ್ ಯಾವ್ದೇ ಆಕ್ಸೈಡ್ಸ್ ಇರ್ಬೋದು ಅಂತ ನಾವಿಲ್ಲಿ ಹೇಳ್ಬೋದು. ಅಥವಾ ಈ ಮೆಟಲ್ ಆಕ್ಸೈಡ್ಸ್ ಇದ್ರು ಕೂಡ ನಡೆಯುತ್ತೆ. ಬಟ್ ಕೊಟ್ಟಿರೋ ಮೆಟಲ್ಸ್ ಅಲ್ಲಿ among the given materials, so carbon is preferable for the high resistors, the resistors with high ranges. The example for non-ohmic resistance, students: copper wire, carbon resistor, diode, tungsten wire. Non-ohmic resistance example. So ohmic resistors andre which obeys Ohm's law anta agate. Non-ohmic anta andre which does not obeys Ohm's law anta agate. Hoda? So non-ohmic ge examples kelta idare. Copper wire, tungsten wire, carbon resistor will obey the Ohm's law, but diodes, yes, very good. So diodes irbodu, solar cells irbodu, ಅಥವಾ LEDs irbodu, ಇದೆಲ್ಲ ಏನ್ ಮಾಡಲ್ಲ, Ohm's law ನ obey ಮಾಡಲ್ಲ. Those are coming under non-ohmic gadgets. ಆಯ್ತಾ? Question number 19. Yes, see 19. All of the following statements are true except conductance is the reciprocal of the resistance and is measured in Simon. B option, Ohm's law is not applicable at a very low and very high temperature. C option, Ohm's law is applicable to semiconductors. Option D, Ohm's law is not applicable to electron tubes, discharge tubes and electrolytes. Yella statement true agide except one. What, everyone is giving one option, but all are choosing between B, C, D. Ohm's law is applicable to semiconductors. Okay, C correct agide, but what about B and D? Ohm's law is no. Ohm's law is applicable to semiconductors. No, the semiconductors do not obey the Ohm's law. So semiconductors Ohm's law na obey madalla. C antu wrong ide. Correct. A correct agide. A is true. What about B and D? Ohm's law is not applicable at very low and very high temperatures. Actually, that is also true, alarm. Ohm's law is applicable at constant temperature. So that is also true. Yes. So A true agide, B true agide, no problem. C is not true. What about D? Ohm's law is not applicable to electron tubes, discharge tubes, and electrolytes. So actually, this is also, yes, this is not applicable. Yes, this is also true statement. Okay, so option C, yes, correct agide. Whatever you told, it is correct. So C option is correct, right? So C option is correct. That is, Ohm's law is applicable to semiconductors. It is not the true statement. Go for the next question. The reciprocal of resistance is. So reciprocal of resistance is called as what? Conductance anta heltivi. Option A is correct. 20th question, option A, students. Which of the following is a vector quantity? Yes, tell me which of the following is a vector quantity. Yes. So 20th is over. Which of the following quantity is a vector quantity? Which of the following is a vector quantity? So current is a scalar quantity. Howda? D. All are telling D. Power. Current density is vector or scalar? Current density is a vector quantity, students. So current density is a vector quantity. Okay. Current is a scalar quantity, but current density is a vector quantity. Power is scalar or vector? Yes. Remember, power is a scalar quantity. So wattless current irli yavade idru kuda scalar quantity ne agatte. So option A, current density. Last two questions, students. The electron drift speed is small and the charge of the electron is also small, but still we obtain large current in the conductor. This is due to the electron drift speed is small and the charge of the electron is also small. So charge matte electron then drift speed ide, both are small, but we obtain the large current in the conductor. This is due to the conducting property of the conductor. The resistance of the conductor is small. The electron number density of the conductor is small. The electron number density of conductor is enormous. Yes, question ಸ್ವಲ್ಪ twist ಇದೆ. So option D ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. What about others? The electron drift speed is small, charge is also small, but we get the large amount of current in the conductor. Drift speed is small, charge is also small, but why we are getting current large? Yes, D. All are saying option D. Yes, correct. Very good. That is option D is the correct answer. Yes, correct agide. Option D is correct. Okay. So 20, the 22nd, I thought 20, 21, 22. Okay. Option D is the correct answer. Last question. On increasing the temperature of the conductor, its resistance increases because relaxation time decreases, mass of the electrons increases, electron density decreases, none of the above. On increasing the temperature of the conductor, its resistance increases. So temperature ಹೆಚ್ಚಾದಾಗೆ resistance ಹೆಚ್ಚಾಗತ್ತೆ. Yes, don't know. So see, the last question answer is what? See here, when the temperature increases, what happens? The speed increases. So temperature ಹೆಚ್ಚಾದಾಗೆ electrons speed ಹೆಚ್ಚಾಗತ್ತೆ. So electrons speed ಹೆಚ್ಚಾದಾಗ the relaxation time decreases. So mass ಗೆ relate ಇಲ್ಲ, electron density ಗೂ ಏನ್ ಸಂಬಂಧ ಇಲ್ಲ ಇಲ್ಲಿ. ಇಲ್ಲೇನಾಗತ್ತೆ, relaxation time decrease ಆಗತ್ತೆ. So for that reason here what happens? That is the resistance increases. Option A is the correct answer. Okay. So ಯಾರಿಗಾದ್ರೂ ಯಾವ್ದಾದ್ರು ಕ್ವಶನ್ ಅಲ್ಲಿ ಡೌಟ್ ಇದೆಯಾ? So 2-3 marks questions and discuss madana, 5 marks and you will keep for the next. So see students. Yes, anybody is having any doubt? Clear aita? MCQs ella clear aita? Hope so it covered all the concepts in your book. Okay, so see, I'll go for the 2-3 marks questions. Yes, students, reply. Be active. Varshid first day est active irbek ನೀವು. Exams are coming close, preparatories ಇರ್ಬೋದು. Okay, hope so ನಿಮ್ಗೆ ಇದೆಲ್ಲ ರಿವಿಷನ್ ಹೆಲ್ಪ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಅನ್ಕೊಳ್ತೀವಿ. ಆಯ್ತಾ? ಸೊ ನೋಡಿ, 2-3 marks questions. State and explain Ohm's law and hence define Ohm. Very simple question. So state and explain Ohm's law. That is, at given physical constants, the potential difference is directly proportional to the electric current. So this is the statement for the Ohm's law. So bari ishte bari bedi state define andaga explain ಅಂದ್ರೆ words ಅಲ್ಲಿ ನೀಟಾಗಿ ಬರೀರಿ ಆಯ್ತಾ. That is, at given constant physical conditions, the potential difference is directly proportional to the electric current. Okay, hence define ohm anta helidare. That is V is equal to I into R. So define ohm andre 1 ohm anna define ಮಾಡಬೇಕಾಗಿದೆ. When the potential difference is 1 volt for the 1 ampere of current, then the resistance is said to be what? 1 ohm. The resistance is said to be 1 ohm. Question first one is completed. Ohm's law statement and define 1 ohm. So ಈ lesson ಅಲ್ಲಿ define 1 ampere ಅಂತ ಬರ್ಬೋದು, define 1 coulomb ಅಂತ ಬರ್ಬೋದು, ಅಥವಾ define the unit of current, define the unit of charge, define 1 ohm, define 1 volt, ಈ ತರ questions ಬರುತ್ತೆ. So formula perfect ಮಾಡಿ ನಿಮ್ಗೆ ಅಲ್ಲೇ ನೆನಪು ಬಿಡುತ್ತೆ ಏನೇನಿದೆ ಅಂತ. So formula perfect ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ actually 2 advantages. One, definitions help ಆಗುತ್ತೆ. Second, it will help you for the numerical also. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? Third advantage is it will help you for the competitive exams. See, mention 2 limitations of Ohm's law, students. Yes, what are the limitations of Ohm's law? So Ohm's law is applicable only for the ohmic devices ಅಂತ ಹೇಳ್ತಾರೆ. Ohm's law is applicable at constant physical conditions like temperature and all ಅಂತ ಹೇಳ್ಬೋದು. It does not applicable to the semiconductors. Yes. The relation between voltage and current depends on the sign of voltage. Okay, Ohm's law is applicable when the temperature of the conductor is constant. Yes, very good. Correct agide. So these are the points which you can write it for the Ohm's law. The third question, derive an expression for drift velocity of the free electrons in a conductor. Okay, so the derivation ide lasting madana. We will go for question number 4, 5, 6 first. Derive, we will do it at the end. Define relaxation time, drift velocity, mobility, conductivity, and mention its unit. So relaxation time is nothing but what? The time interval between the two successive collision. The time interval between the two successive collision is called as what? It is called as the relaxation time anta ಹೇಳ್ತಾರೆ. Drift velocity ನಾವು first ಹೇಳಿದ್ವಿ. Drift velocity is nothing but drift velocity define ಮಾಡಿಲ್ಲ. Drift velocity is defined as it is the velocity with which the electrons get drifted when it is applied for the electric field. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಗೆ ಇಲೆಕ್ಟ್ರಾನ್ಸ್ ಸಬ್ಜೆಕ್ಟ್ ಮಾಡಿದಾಗ ಅದು ಯಾವ ವೆಲಾಸಿಟಿ ನ ಮೂವ್ ಆಗುತ್ತೆ ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ದಿ ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊ mobility we define mobility is the ratio of drift to velocity per unit electric field. Conductivity is the reciprocal of resistivity ಅಂತ ಹೇಳ್ಬೋದು ಆಯ್ತಾ. ಸೊ ಎಲ್ಲದದ್ದು ಯೂನಿಟ್ ಕೇಳಿದರೆ ಆಲ್ರೆಡಿ ಮೊಬಿಲಿಟಿ ಯೂನಿಟ್ ಅನ್ನು ನೋಡಿದ್ವಿ ನಾವು, ದಟ್ ಇಸ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಪರ್ ವೋಲ್ಟ್ ಪರ್ ಸೆಕೆಂಡ್ ಅಂತ ಇತ್ತು. conductivity the reciprocal of resistivity, so it is mho Simon ಅಂತ ಬರೀರಿ. ಓಕೆ, ನಾಟ್ ಸೈಮನ್, ದಟ್ ಇಸ್ ಸೈಮನ್ ಪರ್ ಮೀಟರ್ ಅಂತ ಆಗತ್ತೆ. resistivity is ohm per meter, so here it is per ohm meter. ಆಯ್ತಾ. ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ, ಸೊ ವೆಲಾಸಿಟಿ ಯಾವುದೇ ಇರಲಿ ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್, ರಿಲ್ಯಾಕ್ಸೇಷನ್ ಟೈಮ್ ಇಸ್ ಸೆಕೆಂಡ್ ಇಟ್ ಸೆಲ್ಫ್. ದೆನ್ ದ ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್, ಸ್ಟೇಟ್ ಕಿರ್ಚಾಫ್ಸ್ ಲಾಸ್. ಫಸ್ಟ್ ಹೇಳಿದ್ವಿ ಸ್ಟೇಟ್ ಕಿರ್ಚಾಫ್ಸ್ ಲಾ. ಫಸ್ಟ್ ಲಾ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ದ ಜಂಕ್ಷನ್ ರೂಲ್ ಅಂತ ಹೇಳ್ತಾರೆ. ದ ಕರೆಂಟ್ ಎಂಟ್ರಿಂಗ್ ದ ಜಂಕ್ಷನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ದಿ ಕರೆಂಟ್ ಲಿವಿಂಗ್ ದ ಜಂಕ್ಷನ್ ಅಂತ ಹೇಳ್ಬೋದು. ದಟ್ ಇಸ್ ಆಫ್ I is equal to 0. It is also conservation of charge ಅಂತ ಆಗತ್ತೆ. ಸೆಕೆಂಡ್, ದ ಕಿರ್ಚಾಫ್ಸ್ ಸೆಕೆಂಡ್ ಲಾ, it is also called as the voltage law, or it is also called as the loop law ಅಂತ ಕೂಡ ಹೇಳ್ತಾರೆ. It gives the conservation of energy. So ಏನ್ ಹೇಳ್ತಾರೆ, it is the summation of the potential difference is equal to 0. The summation of the potential difference across the closed circuit is equal to 0. So this is Kirchhoff's second law. And the next question, what is the advantage of potentiometer over voltmeter? So as I told you, potentiometer is a device which is used to measure the potential difference across the 2 points. Voltmeter kuda potential difference ನೀವು measure ಮಾಡ್ಲಿಕ್ಕೆನೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಹಾಗಾದ್ರೆ ಅಡ್ವಾಂಟೇಜ್ ಏನಿದೆ? ಎಸ್, ಪೊಟೆನ್ಶಿಯೋಮೀಟರ್ ನೀವು ಕಲ್ತಿದ್ದೀರಾ ಇಲ್ಲ ಗೊತ್ತಿಲ್ಲ, ಆಕ್ಚುಲಿ ಸ್ವಲ್ಪ ಡಿಲೀಟ್ ಆಗಿದೆ, ಬಟ್ ವಿ ವಿಲ್ ಸಿ ಎಕ್ಸ್ಟ್ರಾ ಪಾಯಿಂಟ್ ನೋಡಿದ್ರೆ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ಓಕೆ, ಡಿಲೀಟೆಡ್. ಇಫ್ ಯು ಆರ್ ನಾಟ್ ಇಂಟ್ರೆಸ್ಟೆಡ್, ನೋ ಇಟ್ಸ್ ಓಕೆ, ನೋ ಪ್ರಾಬ್ಲಮ್. ಜಸ್ಟ್ ನಾನು ನಿಮ್ಗೆ ಹೇಳ್ತೀನಿ, ಜಸ್ಟ್ ಆಸ್ ಅ ಎಕ್ಸ್ಟ್ರಾ ಪಾಯಿಂಟ್ ಯು ಕ್ಯಾನ್ ರಿಮೆಂಬರ್ ಇಟ್. ಅಡ್ವಾಂಟೇಜಸ್ ಆಫ್ ಪೊಟೆನ್ಶಿಯೋಮೀಟರ್ ಓವರ್ ವೋಲ್ಟ್ಮೀಟರ್. ಸೊ ಕಾಮನ್ ಪಾಯಿಂಟ್ಸ್ ಏನಂದ್ರೆ, ಬೋತ್ ಆರ್ ಯೂಸ್ ಟು ಮೇಜರ್ ದಿ ಏನದು, ದಟ್ ಇಸ್ both are used to measure the potential difference itself. But what is the advantage ಅಂತ ಹೇಳಿದ್ರೆ, here potentiometer ಏನಿದೆ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, potentiometer does not draw, it ಏನ್ ಮಾಡಲ್ಲ, it does not draw current from the circuit in which it is used for the measurement. ಸೊ ಎರಡು ಏನ್ ಮಾಡತ್ತೆ, ವೋಲ್ಟೇಜ್ ಅನ್ನ ಮೆಜರ್ ಮಾಡಿದ್ರು ಕೂಡ ವೋಲ್ಟ್ ಮೀಟರ್ ವಿಲ್ ಟ್ರೈ ಟು ಯುಟಿಲೈಸ್ ದ ಕರೆಂಟ್ ಫ್ರಮ್ ದ circuit, but potentiometer will not utilize the current for the measurement of the potential difference in the given circuit ಅಂತ ಹೇಳ್ಬೋದು. ಸೊ ಅಲ್ಲೇನು ಕರೆಂಟ್, ಎಕ್ಸ್ಟ್ರಾ ಕರೆಂಟ್ಸ್ ಪೊಟೆನ್ಶಿಯೋಮೀಟರ್ ಡಿವೈಸ್ ಯೂಸ್ ಮಾಡಲ್ಲ, ಬಟ್ ವೋಲ್ಟ್ ಮೀಟರ್ ವಿಲ್ ಯೂಸ್ ಸಮ್ ಕರೆಂಟ್ ಫ್ರಮ್ ದ ಗಿವನ್ ಸರ್ಕ್ಯೂಟ್. ದಟ್ ಇಸ್ ದ ಮೇನ್ ಅಡ್ವಾಂಟೇಜ್ ಫ್ರಮ್ ದಟ್. That is from potentiometer to voltmeter. The last question for today's class, that is derive the expression for drift velocity of free electrons in a conductor. So drift velocity ಈ ತರ ಕೂಡ ಕೇಳ್ತಾರೆ ಕೆಲವೊಂದ್ಸಲಿ. ಇದೇ ಕ್ವಶನ್ ಅನ್ನ ಡಿರೈವ್ I is equal to NEAVD ಅಂತ ಹೇಳ್ಬೋದು, ಅಥವಾ derive the expression for current in terms of drift velocity ಅಂತ ಕೂಡ ಹೇಳ್ತಾರೆ. So same question can be asked in 3 to 4 different forms. ಆಯ್ತಾ? That is I is equal to NEAVD. This you have to derive it now. Okay students, so see how to do this. So first what you need to do, just one show conductor ಅಂತ ತೋರಿಸಿ, ಇದ್ರ ಒಳಗಡೆ electrons ಅಂತ ತೋರಿಸಿ, electrons direction ಈ ಕಡೆ ಇರ್ಲಿ, electric field ತೋರಿಸಬಹುದು, VD ಅಂತ drift velocity ತೋರಿಸಬಹುದು. Then after that you write there ಏನೇನ್ points consider ಮಾಡಿದೀರಾ, just write it. Consider a conductor having n number of electrons E be the electric field, and Vd be the drift velocity for the given conductor. N be the number of electrons, E be the charge of the electron anta one paragraph barkoli. So after writing that, you can start with the derivation. So first diagram, second ಏನೇನ್ terms use ಮಾಡ್ತಾ ಇದ್ದೀರಾ, just one small points ಬರ್ಕೊಂಡ್ರೆ ಆಯ್ತು. Very simple derivation. So directly what you can write here, we know that from the definition of the current, I is equal to Q by T. I is equal to Q by T, that is charge per unit time anta ಹೇಳ್ತೀವಿ. This is my equation 1. The second equation is what? The total number of electrons, the number of electrons in the conductor, the number of electrons in the conductor is equal to N into volume of the conductor. N into volume of the conductor. So N ಅದೇ ರೀತಿಯಾಗಿ ಇಡ್ಲಿ, volume ಅನ್ನ ನಾನು ಇಲ್ಲಿ A into L ಅಂತ ಬರಿತೀನಿ. So volume is nothing but what? Length into breadth into height. Volume is nothing but length into breadth into height. So here breadth into height ಅಥವಾ ಎಲ್ಲ ನಾವಿಲ್ಲಿ L ಅಂತ dimension consider ಮಾಡಿದ್ರೆ length into breadth is area ಆಗತ್ತೆ. So A into L ಅಂತ ಉಳಿಯುತ್ತೆ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? So first equation, current is equal to charge per unit time. Second equation, number of electrons in the conductor is N into V. V is equal to A into L, equation 2. Now, the total free charge in the conductor is, the total free charge in the conductor is Q is equal to N into AL into E. So charge, single charge value ಏನಿದೆ E ಇದೆ ಆಯ್ತಾ. ನಮ್ಮ ಹತ್ರ ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇದೆ, N into A into L ಇದೆ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? We have the number of electrons N into A into L, ಮತ್ತೆ ಈಚ್ ಚಾರ್ಜ್ ಎಷ್ಟಿದೆ E ಅಂತ ಇದೆ. ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ಅಂದ್ರೆ ನಾನು ಇಲ್ಲೊಂದು ಪಾಯಿಂಟ್ ಹೇಳ್ತೀನಿ ಕೇಳಿ. ಸೊ ನಿಮ್ಮ ಹತ್ರ 1 ಪೆನ್ ಇದೆ, ಅದ್ರ ವ್ಯಾಲ್ಯೂ 10 rupees ಇದ್ದಾಗ 10 ಪೆನ್ ವ್ಯಾಲ್ಯೂ ಏನಾಗತ್ತೆ ಅಂತ ಆಯ್ತಾ. ಸೊ 10 into whatever that number is there ಅದನ್ನ ಮಾಡ್ತೀರಾ. ಅದೇ ರೀತಿ number of electrons in the conductor is NaEl, NaL ಅಂತ ಇಲ್ಲಿ ಮೇಲ್ಗಡೆ equation 2 ದಲ್ಲಿದೆ, multiplied by each charge Ne. Next, so substitute this equation 3 in equation 1, that is I is equal to NaL into E divided by T. ಆಯ್ತಾ. So now L by T ಇಲ್ಲೇನ್ L by T ಬರ್ಕೊಂಡಿದ್ದೀರಾ. So here whatever your L by T is there ಅಲ್ಲ, L by T ಅಂದ್ರೆ distance by time. So distance upon time is nothing but what? Velocity. So it is NaVd into E. This is the expression for current in terms of drift velocity. ಅಥವಾ ಅವ್ರು drift velocity ಕೇಳಿರೋದ್ರಿಂದ ಏನ್ ಮಾಡ್ಕೊಳ್ಳಿ, Vd is equal to I divided by Na into E. Na into E. So this is the derivation what you can do. Is it clear, students? ಅರ್ಥ ಆಯ್ತಾ? ರಿಪೀಟ್ ಮಾಡ್ಬೇಕಾ? Derive the expression for drift velocity. I is equal to NeAVd or Vd is equal to NEA. Is it clear, everyone? All the questions what we have discussed today. So current electricity ಸ್ವಲ್ಪ easy ಕೂಡ ಆಗತ್ತೆ. If you do this lesson, you will get minimum 9 marks. 9 to 10 marks ಸಿಗತ್ತೆ. So plus first 2 chapters. Is it clear? Any doubt is there? ಯಾರಿಗಾದ್ರೂ ಏನಾದ್ರೂ doubt ಇದೆಯಾ? Okay. Yes. So in the next class, we will see the 5 marks questions plus numericals ನೋಡೋಣ. Okay na? So thank you, students. Have a great evening and great year. Thank you. So that is drift velocity in terms of current I have derived. ಅದೇ equation ಅನ್ನ modify ಮಾಡ್ಬೋದು ನೀವು. Equation you can modify again. If you want again in the next class, we will continue that. Yes. Expression for conductivity, if you want, I'll do it in the next class. ಅದು ಕೂಡ ಬರೋ ಚಾನ್ಸಸ್ ಇರುತ್ತೆ. ಐ ಥಿಂಕ್ ಡೌನ್ ಕೆಳಗಡೆ ಇದೆ ಕಂಡಕ್ಟಿವಿಟಿ, ನೆಕ್ಸ್ಟ್ 5 ಮಾರ್ಕ್ಸ್ ಅಲ್ಲಿ ಇದೆ, ಅಲ್ಲಿ ನೋಡೋಣ, ಏನ್ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ ಆಯ್ತಾ. ಓಕೆ ಸ್ಟೂಡೆಂಟ್ಸ್, ಥ್ಯಾಂಕ್ ಯು.